And let's switch the topic a little bit to some more fundamental things of what holds the internet together. It's BGP and its communities. And a specific type of one practical problem that starts to appear in the operational community and possible ways of how we could address that. And that's about the deployment or the growth of deployment of 4-byte ASs and what are the policy constructs which are required to express the policy in the context of 4-byte ASs. To express the 32 bits policy constructs in a way that AS this, please do not advertise to AS that, you need two entities which both are 32 bits. And today, with the existing encodings, that's not so easy to do. So to look at the currently available community containers, all of them can provide up to 48 bits of storage space. There are different types. Which treat certain fields whether as an IP address, or just a 16-bit AS number, or as any, say, it's unstructured quantity. But looking into the encodings on the wire, it's clear to see that you cannot squeeze in more than 48 bits into one single community. And in our case, we need 32 plus 32, and that's simply not enough. There is one possible, at least theoretical, option to reuse the IPv6 address-based extended communities. There's enough space to hold the two fields of 32 bits. There's a small practical problem. None of the vendors, at least none of the dominant vendors, seem to implement this and don't necessarily have plans to do that. There is another aspect in the context of semantical validity of such community. The error handling requirements for BGP states that extended communities must be of the length of multiple of 8 bytes. This one gives you 20, and this is a violation of that error handling requirement. And in the best case, that will be treated as a withdrawal, so it basically gives you a little practical value. Then there is, in fact, a specification which defines extended communities for 4-byte ASs. The only thing that it does, it basically renames the global field to represent the 4-byte AS instead of 32-bit quantity on IP or IPv4 address. But the local part, or the remainder of that container, still can only hold 16 bits, not enough. There's a set of specific extended communities used for signaling of all sorts of parameters for layer 2 VPNs, layer 3 VPNs, some other address families. Again, all of them are modeled based on the current 48-bit length field, just they interpret the subfields in a slightly different way. And while it is possible to try to use either vendor-specific implementations or some other creative ways and try to at least mitigate this problem partially, from let's say, again, semantical point of view, this defines another address family, or they are used in the context of another address family. So now, in order to define an IPv4, for example, address filter, you need to rely on constructs which are meant for some different address family. Not necessarily the best practical option. EVPN adds in some changes to the format. Again, it does not change the container itself, it just interprets certain subfields having some specific value flags in this particular case. And that might be a good idea, that you can have a predefined position in an extended community, which means certain predefined operations. But again, this is too short to carry all the policy constructs that we might need. So what can we do here? One of the practical options is that we try to reuse the concept of AS dot needed, used previously in AS 4-byte migration scenarios. Split the 4-byte AS into 2 parts, each having 16 bits, and carry that as 2 extended communities. The other practical option might be to do something on the lines of AS number translation, call it so, where you map 32-bit AS into a spare, stolen, or otherwise available 16-bit AS, and all your policy constructs deal with that mapped 16-bit AS. Or you can also try to rely on the vendor-specific extensions if they are available. A little bit more details about the AS.dot split and the pains related to that. So overall idea is that you decorate the update with multiple communities. Theoretically 2 should be enough, but for practical purposes 3 is more reliable. You treat 1 as an indicator, and then the other 2 actually carrying the whole policy. And that is needed in case where your AS.dot sub-communities that are represented in AS.dot notation clash with the actual 16-bit AS seen in the updates. And again, this relies on heuristics and how flexible your platform can support such policy constructs as match all communities and not necessarily just the first one. And this seems rather fragile. There is another proposal, which is working group draft in the ITF, that defines something really new and flexible and powerful, defining or basically redefining how the communities are being used and what capabilities they might have, with a lot of flexibility, at the same time with a lot of complexity. Yes, the good news is that AS number is treated as a 32-bit quantity. There are also some other goodies there, including the control of the propagation, how far this update might be sent out, and who should be able to receive, not receive, and so on. Something equivalent like a time to live in the data planes. However, this is complex. This is really complex up to the level that vendors don't intend to support this. Yes, it might be a nice theoretical idea, but this is simply too complex to invest developers' resources. On the other hand, from an operational point of view, 2 aspects. One, it's complex to develop in a way that this is defect-free. The other aspect is that policy might need to be changed. So it's not just extending the fields to more bits, it's treating the fields in different ways. So as a summary, while this might seem a good idea, at least at this point of time, this doesn't seem to be practically usable. So, and again, one comment to make on wide communities. This is not an attempt to derail that work, not at all. It has a merit, and possibly something out of that will develop. Just that solution for 32-bit AS accommodation policy for 32-bit AS is needed today. Well, actually, it was needed yesterday, and probably 5 years ago. It's not there yet, and the solution is needed for a very specific problem. So, simple requirements to be able to express 32 plus 32 policy in a compatible or ideally the same way as it's done today for existing 3216 or 1616 policies. So one of the possible ideas, and that should not be seen as a solution, this is just to initiate the discussion. We had some more space into the container to carry 2 32-bit fields. However, due to the error handling requirements, we cannot just extend and add 2 more additional bytes. The overall length of the extended community needs to be a multiple of 8. Therefore, for free, we get 1 of the 32-bit field, and some others can be redefined and reused, for example, for flags or for something else not yet known at this time. Another benefit which can come mostly for free is ability to align the fields at the machine word boundary, 32, possibly 64 bits. That is definitely a plus for the software implementations. So this seems to be one of the possible, not necessarily the single one, but one of the possible solutions for trying to address how to encode the 64-bit communities on the wire. So the discussion, and this is what I would like to hear from your operational feedback. Is this a problem that you see? Is it painful, and if painful, how painful? What would your thoughts be? What else would you like to see in this, say, imaginary new community? With practical comment on that. In order for this to come to any deployability, this needs to be implemented by vendors. We might add many things into that and make it complex, and that will just dramatically reduce the chances that vendors will agree to implement that. This needs to say simple, simple covering the minimum set of practical requirements. That's basically it from my side, so I would like to hear your views, opinions, complaints, pains, and anything else from your side.
Joe Snyders, NTT. Thank you for addressing this issue. I think it's long overdue. 32-bit ASN owners should not be second citizens as they are today. And for instance, if you look at NTT's BGP communities, what we have published, you can see that some of the traffic engineering communities we offer can only work for 16-bit ASNs. They cannot work for 32-bit ASNs. And I think we'll see more and more 32-bit ASNs coming because the RER pools are depleted. And it is deplorable that in the IETF there was never anything tangible came out of that. And we're stuck with literally nothing at this point, except for your effort and white communities. So, if anything, you have my support to walk down this path, because there are things I can point at that are broken at this very moment, which a 64-bit or 96-bit community would solve for me. So, thank you.
Right, thank you for that.
So this is two-parted, I think. First off, to John, kind of. So the control communities that you have, I suppose that they are for your peers. I'll walk towards you so you can actually respond.
We have two types of communities most transit providers do. We have informational communities that tell you something about the origin, where we learned the route. And we have action communities which trigger something in our network. And those are only available to customers.
Right, but they are about the peers, right?
Yes.
Do you peer with anyone that has 32-bit AS?
That is an issue. We cannot configure it.
Right, okay, so what I'm getting at, I think, is that usually big networks like that don't really have the need to do this for 32-bit. I know at least that with my experience, we never had this issue, really. Everything they implement control communities for are 16-bit ASNs. It's really something more. But second part, the question for you. How do you perceive this in relation to white communities? Let's say when you have white communities, is there a need for this?
So let me first try to address the first part. Now I'll answer that with a question. You don't have this problem for how long? How do you think?
Well, I already have it today. I can literally not configure the network to accommodate this use case, and I consider that an issue.
So, given that AS4 numbers are being allocated, it's probably a question of time. They will appear, and you will end up pairing with somebody being addressed with AS4. So probably saying that today we don't have this problem. Well, we didn't have this problem for the last 5 years. Let's be realistic. But as more AS4s get deployed, this problem has likelihood of showing up.
I'm not saying that we, as the internet, don't have this problem. I was just saying that we, as the operator that I was working for then and now, probably don't have that problem. So that was a very ignorant view. I mean, I do agree that this is a good thing overall, but I am a little bit concerned that, you have potentially competing things here. If you get wide in, then what you do with this, or the other way around, will it lose traction if you implement just a very basic version of it, right?
Okay, so in my view, 64-bit communities and wide communities are different things. Wide communities bring 32-bit awareness probably as just an artifact or a side feature. The fields are based on 32-bit boundaries, and that's a good thing to design something from the beginning. The biggest benefit of wide communities is ability to express different policy constructs, which we don't easily have today. Another question is whether we really need that, and probably today there are no use cases, or at least broad use cases for that. And it's kind of a, say, closed-loop situation that we don't have use cases because we don't have constructs, and we don't develop constructs because we don't have use cases. If the constructs show up in the name of wide communities, probably use cases will follow. Now, this, say, small approach to a small problem is trying to address one single pain point with one single point solution. Again, it's not an attempt to derail the wide communities. This is something, again, which should have been a long time ago, and this is just addressing, say, historical oversight, if I may call that. And very likely it will be, say, a temporary or transit type of solution to address this until we get either wide communities in the current form as they are standardized, specified, or something else along the lines of wide communities. For a very simple reason. Vendors don't show much of support for implementing wide communities, at least today, due to the complexity. So maybe we need to simplify wide communities or split that into parts addressing specific problems. Maybe. I don't have an answer for that. But I would see wide communities and this 64-bit approach being probably orthogonal. I cannot say parallel, but probably those are orthogonal.
So, with the risk of dragging out this conversation very long, but so with the wide communities, what's the problem? Is it encoding on the wire, or, for example, that you have standardized actions such as propagation control, and the router would probably need to implement that, and it's not done in an operator-defined policy, rather it's actually part of the router, like one of the well-known, no advertise communities or something like that. So which is the problem?
Policy expressing
all of them.
Exactly. Expressing the policy is one thing. That's operational complexity. You might end up needing to redefine your policy constructs, basically your policy. But on another hand, in order to have that functionality, vendors need to code it. And coding for rather complex TLB-based constructs in a defect-free way for something so critical as BGP, it's not that trivial, and that's the reason why they are not too keen on doing that. This is a complex task. So the complexity which is in the specification translates into the engineering complexity. And it's not only to code the TLB parser, you need quite a lot of other things. For example, your configuration schema, which will be really different than the current policy. Constructs all sorts of validators, internal machinery, and it's far more than just decoding and encoding the TLBs and sending out on the wire.
And to supplement what you're saying, I think white communities are a very novel way of communicating intentions to a neighbor, while 64-bit communities is just an upgraded version of the 32-bit communities. With 32-bit communities and 64, we communicate an integer to each other. And the meaning of that integer is an agreement we made out of band. With white communities, I'm not communicating an integer to you, I'm communicating a desired policy, which is vastly different technology. So if if I have to put money on Google finished first, it will be 64-bit communities, because it's not a change in thinking, it's just more address space or bigger integer space. So that for me is the selling point.
I agree with that. I mean, it is a way to get going much easier. On the other hand, if you look at the BGP communities supported by most carriers, they are doing pretty much the same thing. It's, depending here, doing that, setting the IGP metric or no export or whatever. So it would kind of be nice to have that standardized way, I suppose, of doing that. But sure, I mean, I'm not arguing against this really. It's more curiosity. I would just like to say that it would be nice, I think, to have more than 64 bits, actually. What you see today, when you have the 16-bit ASS, a lot of stuff, a lot of vendors, operators, they overload like the private AS space, and that tells you kind of the function, if you want to overload, if you want to prepend towards someone, then you're using a private AS to communicate that, and the second bit of it is to whom to do that, and it would be nice that we get, 96, I don't know, the next something boundary to do that, regardless if we're, defining the standard stuff that White is doing, but just if you want that, I see you have some research.
So with this encoding, you get 96 for free. Well, actually, you get 32 additional ones for free.
Right, so as long as I can set them in my router policy, that would be nice. If they're actually reserved, I suspect that my vendor might not implement a function for me to set them in my policy.
So one of the ideas is, as the second point shows, that you can use that third reserve field, for example, for controlling the scope where it gets propagated to.
Right,
That's
that would be excellent. I suppose I'm just saying that if it's reserved, it should probably be, I don't know, user specified or something, so we still have the ability to
possibly use for scope control, yeah. So.
Okay.
I'd really swap that sentence and just make it local part.
Fine.
Deal.
And actually, just to comment on the first part that you were saying, the use case for this, for the particular problem, is to specify the policy which has the second part as a 32-bit AS. So AS this, do not advertise to AS that. Where this and that are both AS4s. It's not some, say, policy modifying community. Prepend this, append that, change this, but to specify where the prefix should or should not be propagated.
Okay. I'm not quite sure if I'm following, but to me, one part of it is usually you kind of define a function, what you want it to do, and announce it, do not announce it, prepend, do something, and the other part says where, kind of.
Well, possibly you can do that in different ways. This is a selective crowd propagation control. That you specify to which, so basically to your neighbor's neighbor, to which your neighbor's neighbor this will be advertised or not advertised, provided that your neighbor supports such policy.
But are you implying that this is part of the standard? I mean, this is defined by the two networks that exchange routes using this, right?
Exactly.
So someone else could use it for something completely different.
Yes, definitely. This is just one use case which requires wide entities to support it.
Right. So the global part, I think it's elegant, I suppose, that the global part is for my AS. So if I have a 32-bit, that would just occupy that whole thing. And the local part would be probably my peer.
Yes.
But then where do the function go? Do not announce, prepend, blah, blah, blah. There's We have to use one of the other feeds. And today we're putting typically a private AS in the global part.
So in that particular use case, the global part would be your peer, and the local part would be the AS to which you don't want to advertise from that peer.
But that goes counter to years of tradition in this space.
There might be different use cases that require that. It's not necessary public peering for maybe for address patterns.
Well, if anything, I suggest we continue this conversation per email between interested parties, not to bite into the beer drinking. I look forward to discussing this one.
Thank you.
Okay, well, thank you very much for that great presentation.